Okay, now we'll do the analysis of a BJT amplifier circuit using H parameters. First of all, let's understand the transistor models. This is the basic transistor model, a generalized model where we have HIE here, HR here, HR into the output. Let's say this is VO, then we'll have HRVO here. Let's understand this for common emitter first. Common emitter. This is our common emitter circuit. This is collector, this is base, this is emitter. Emitter is common. In a common emitter circuit, we take input at base and output at collector. Therefore, our input is this base, this is our common emitter, and this is collector, the output is collector. Therefore, this is what? This is VC and this is IB. This is IB. Clear? Base. So we can write HRVC here and this is HFIB. So this is the model for common emitter. Now, in case of, this was for common emitter CE. Clear? Understand this properly. For common emitter, we take input at base. Therefore, IB is here, HFIB, and output at collector. So output voltage is VC. So this is HRVC. These are the parameters. Now we'll see what for common collector. Let's see. In case of common collector, what we do? Common collector means this is common, this is grounded. Then we take input at base and we take output at emitter. This is common collector. So what changes we will have to make? Our common is collector, that is this is C, and input is at base, no issue. Output is emitter, E. Therefore this VC becomes VE. Now what we will do? This is HRVE. As a matter of fact, you can put HRC also to make it, to make the parameter for common collector. So this will be HIC, this is HFC, IB, this is HO and this is VE. Clear? So in case of common collector, we have input at base and output at emitter. In case of common base, what if we have a CB configuration? CB, then what? CB means like this. This is base which is grounded. This is emitter, E. We take input at emitter, and this is collector at which we take the output. So in case of common base, this is again collector C. What is this? The common one is base and input we take at emitter. So this is emitter. Now IB becomes IE and this becomes HIE. This is a common base, sorry. So HIB, HRB, and output is VC. So this is VC, collector. Clear? This is VC now. So this is HFB for base and the input current is IE. Okay? So in case of common base, our input is at emitter, our output is at collector. So this will be the figure. I hope you understand this. So now what we'll do? We'll take our common emitter model and analyze different parameters. In case of common emitter, this is E and this is B. This is base, input is at base. This is now IB and this is common emitter, so this will be HIE, this will be HRE, output is VC, no issue. This is now HOE, this is HFE. Clear? So this for common emitter, this is the case. Base is input, IB is the current, output voltage is VC. We have input voltage. Input voltage is VB. Now we are using small letters to show the AC currents and voltages. So VB is a function of IB and output voltage, and the second one IC, it is another function of IB and VC. Clear? So let's write the equation. VB is equal to HIE-IB plus HRE-VC, and IC is HFE-IB, and this is VC. If you forget the parameters, try to remember that this is input, this is the reverse transfer, this is the forward transfer, and this is the output. So HI, then HR, then HF, and then HO. And input side we take the voltage, and output side we take the current. Okay. So what is HIE? HIE, it is defined as, I had told you, this by this, keeping this equal to 0. Now here what we do, we take partial derivatives. So we take partial derivative of VB by IB. Actually partial derivative of the function 1 with respect to IB, that is del VB by IB, keeping VC constant. This is the way we write. This means derivative of VB with respect to IB, keeping VC constant. So this is HIE. Second is HRE. This is defined as del VB by del VC, keeping IB constant. Okay. This is HRE. Now third one, HFE. This is defined as del IC by del IB, keeping VC constant. And finally HOE is del IC by del VC, keeping IB constant. These things you should remember, because you'll need this when you will have to convert the parameters from one configuration to another. So this is a concept that should be kept in mind. You don't have to learn it by heart, but you should keep this in mind. But this equation and this equation, these two equations you should learn by heart. You shouldn't forget it. Okay. Now let's say this is our two-port network. So this is port 1 and this is port 2. What we do, we attach a load in the output port. Let this be ZL. This is what? I2. If this is I2, this is IL. From here what you get? Load is minus of I2, or I2 is minus of IL. This is what? This is V2. This is our V1. Here, if you attach a source, it will have its internal resistance. Let's say it is RS, and this is our source VS, and this is current I1. So this is a generalized representation for which we can write the equation V1 is equal to HI into I1 plus HR into V2. Then I2 is equal to HF I1 plus HO V2. So this is the generalized equation. Okay. If you are not able to conceive this graphically, let's take a common emitter circuit. This is collector, this is base. So what we do, we attach a resistor here. in the output side. This is our ZL. Let this be admittance. So this is, let this be impedance. So this is ZL. This is how is represented in the circuit form, or it can be represented as this. RL or ZL, whatever you write. So this is representation, and in the input side we represent it like this. This is RS, this is VS. Clear? So this is the part that we actually now I am using the model to represent this and this. Okay, you understand this is transistor. Now let me draw the hybrid model. What is hybrid model? So load is like this. Let this be impedance ZL, and source is like this. Clear? From here we get those equations. Now I am deriving the formula for current gain, voltage gain, input impedance, output impedance or admittance. Let's see current gain. Current gain is defined as IL, current in the load, by input current. Clear? This is the definition of current gain. What is IL? IL is basically I2 minus I2. So this is now minus I2 by I1. Now we have I2 from here. See, these are our standard equations. We have I2 from this equation. I2 is equal to HF I1 plus HO V2. I am not using any E or C or B. This is generalized derivation, applicable for all. So I2 is this, but V2 is what? V2 is ZL into IL, load into current, that is minus ZL into I2, because IL is minus I2. So we can write here HF I1 minus HO into V2. This is ZL I2, ZL I2. Now we can put this on one side, that is HO ZL I2 is equal to HF I1. So I2 by I1 we get from here. Therefore this is minus HF 1 plus HO ZL. Clear? What is voltage gain? AV. It is defined as output voltage, V2 by input voltage, V1. Very simple. So we have V2. V2 is equal to, now we will define input impedance. Input impedance. So Zi will be Vi by, Vi not, V1 by I1, that is voltage by current in the input. What is V1? V1 is there HI I1 plus HR V2 by I1, HR V2. So V2 is what? V2 is our output voltage, that is I2 into ZL. This we know. Therefore, we can write V2, and further we can do one more thing. We can put I2 by I1 into I1 into ZL. We can write like this, and this is what? This is AI, that is current gain. So this is current gain into I1 into ZL. So now I am writing it here. This is HI, I1 cancels, and then plus HR into, HR into AI into ZL. So I am writing AI into HR into ZL. So we have the formula for Z input impedance. Okay, you can put the value that we got for AI into this and get value independent of AI all dependent on the Zi dependent only on H parameters and ZL. So that is up to you. Then we calculate our voltage gain. Voltage gain. What is voltage gain? Voltage gain is defined as V2 by V1. No issue. V2 is here. See, V2 is basically this one. So it is AI into I1 into ZL by this is V1, or this is what? AI ZL by V1 minus I1. And what is V1 minus I1? V1 by I1, that is ZI, input impedance. So this is AI Z load by Z input. This is our voltage gain. Clear? So we have derived formula for current gain, voltage gain and input impedance. Now we'll see what is the voltage gain and current gain taking the input resistance RS into account. See, this is RS, this is VS. So what we can write is, this is ZI plus minus V1, this is I1, and we can see the equivalent also, that will be a current source and this resistance. So let's start with this. So what is the voltage gain taking this source into account? This will be our output voltage by Vs instead of V1, or this can be written as V2 by V1 into V1 by Vs. This is our voltage gain without the source into V1 by Vs. What is V1 by Vs? See, V1 is simply I1 into Z input, and Vs, if you try to equate this, this will be minus Vs if we take KVL. So minus Vs plus Rs plus Zi, Rs plus Zi into I1 equal to 0. From here what we get? We get I1 is equal to, or we have to take V1 by Vs. So I am writing it here. So I1 is equal to Vs by this Rs plus Zi, and this is Zi. Therefore V1 by Vs is what? Zi by this. We have to find V1 by Vs. So AVs is equal to, see, AV into V1 by Vs, V1 by Vs. So this is Zi by Rs plus Zi. So the voltage gain taking the source resistance into account is this thing. We can use one more thing. We had seen that AV was AI into ZL by Zi, or AV into Zi is equal to AI into ZL. This you should keep in mind. So AV into Zi, you can write it AI ZL by Rs plus Zi. Okay, now I'm rubbing this. Now let's see current gain. Current gain taking the source resistance into account, that is AIS. So AIS will be the output current by source current, that is I2 by I1. We can write it like this, into I1 by IS. That is, this is current gain AI. So this is AI I1 by IS. Now we'll have to see what is I1 by IS. Now we can have it like this. IS and this is Rs. You must have studied Norton and Thevenin's equivalent. So this is IS, this is Rs. So let's see what's the relation between I1 and IS. See, I1 is this plus this, but if you take V1 in this direction, then what we have? We have V1 by Rs in this direction. This is the voltage and this is resistance. So V1 by Rs is in this direction because this is plus minus, plus is this. So what is I1? Is minus I1, these are exiting, see, and this is entering, minus V1 by Rs, that is 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 equal to I1 plus this, equal to 0. Now what is V1? V1 is I1 into Zi. So this is 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 equal to I1 plus V1, that is I1 into Zi. That is, this becomes what? This becomes Rs plus Zi by Rs into I1. What we have to take? We have to take I1 by Is. So I1 by Is is Ai into, see, Rs by Rs plus Zi. So this is our current gain when we have taken the source resistance into account. Okay. Now we will see the output admittance. You understand admittance? We have resistance, then we have conductance. Conductance is 1 by resistance, inverse of resistance. Similarly, if we have impedance, we will have admittance, that is Y. Admittance is basically inverse of impedance. So what is the output admittance? Instead of output impedance, we take, the convention is to take output admittance. What it will be? This will be I2, this is the output current by V2 at source voltage equal to 0. So this is the definition of output admittance, that you short circuit the input voltage, source voltage. So Y0 is I2 by V2 at Vs equal to 0. Let's see what is I2. I2 is given here, HF I1 plus HOV2. So dividing by V2, what do we get? We get HF I1 by V2 plus HO. So we have to find I1 by V2 at Vs equal to 0. Let's see the circuit. The circuit was like this. This is HI, this is RS, this is VS, this is HR into V2. This is the input circuit. Now at Vs equal to 0 means short circuiting this and this current is I1 RS plus HI into I1 plus HR V2 is equal to 0. This means what we have to I1 by V2. So I1 by V2 is equal to minus HR RS plus HI. So I'm putting it here. What we will get? This is HO. This will become minus. So minus HF into HR by RS plus HI. So this is the expression for Y0, output admittance. Hope you have understood this. Now we will solve a question utilizing these parameters to find a solution.